I'm live! Woohoo! This is Math 60 Intermediate Algebra, and this is 7.4. We're in the middle of radical. It's a radical party, and we have landed on what is possibly the least favorite thing in the whole history of everything for everyone. In fact, so much so that everyone forgets they learned this. So hopefully you don't forget it. Hopefully we go over it in a way that makes it make sense. This is a concept called simplest radical form. This is an agreement for how to be polite with your radicals. So in other words, do not leave radicals lying around unless they follow the following rules. Everything that can be simplified in each radical is simplified. So if you've got the square root of 4, you write that as 2. Don't leave a square root of 4 lying around. There are no radicals in the denominator. This is a big point. This is going to be the bane of your existence for the next 15 minutes, plus whatever homework you do. And there are no fractions inside any radicals. That is a sneaky way to try to do an end run around number 2. So basically no radicals mixed with denominators. It's just bad news. It just does not work. Okay, so it's like mayonnaise and orange juice. It just does not work together. So let's talk about rationalizing the denominator. Rationalize in English means to, try to explain something that maybe should not be, or to, basically explain. But in math, to rationalize is to make rational. So in other words, to take something out of the irrational realm and make it rational. If you have a fraction and you have a bunch of radicals running around, you're usually not going to be able to rationalize both the top and the bottom. So someone long before me, someone who has been dead for probably hundreds of years, decided that the best way to do this would be to always favor the denominator, make the bottom part of a fraction be nice, no matter what horrible horrors you have to visit upon the numerator at the top. So here we go. What the heck does this mean? Well, it means if you have this fraction, right? So the fraction 3 over radical 2. This violates this problem. Oops, I can't point to something you guys can't see. Sorry about that. There are no radicals in the denominator. Oh my God, there's a radical in the denominator. Think of the children. Oh no. I know most of the children would be like, I'm cool with that. That's fine. It's the adults who get upset about things. Keep that in mind. Whenever anyone ever says think of the children, they really mean think of the adults. Fun facts about the universe. So what can I do? Well, what if I took this fraction and I multiplied top and bottom by radical 2, or square root of 2, right? What happens here? Well, square root of 2 times square root of 2 is square root of 2 times 2, which is the square root of 4, which is 2. Woohoo! Now up on top, I get 3 times radical 2, which, as you notice, does not simplify. So we've got this original problem. We had the radical on the bottom. And this one has the radical on top. And we're going to call this one better. Yay! Because someone else decided this. Now, it turns out this is going to be easier to work with, because I don't want to make everyone shudder in fear, but yes, we're going to have to add fractions that look like this together, and finding common denominators when you've got square roots in the denominator is going to be a pain in the tuchus. So instead, what we're going to do is we're going to clean up the denominator and put all of our mess here. And yes, you do bring up a point, invisible people I can't actually hear. This is very much like if someone says you need to clean up your room and you just take everything that's messy and shove it in your closet. The numerator becomes the closet. We're just shoving all the radicals up into the numerator. And yes, I agree, we're not really changing anything, which is important. Multiplying by radical 2 over radical 2, this, let me get out my handy dandy highlighter. Radical 2, oh my gosh, it smeared even though I printed it. Oh no, maybe I just have a very smeary highlighter pen. Maybe that's its superpower. smears anything. I don't see how that could be helpful, but there could be kind of like some other Avengers where, oh no, somebody needs to smear this right now, and I'll help you. I am super smear. Okay, so radical 2 over radical 2 equals 1. So we're not changing the value of the fraction. That's what's most important. This fraction equals, equals, equals. Equals are very serious to mathematicians. We do not take these lightly. If I say two things are equal, that means they are equal. Okay, so shall we rationalize some denominators? Woohoo! Okay, radical 7/3 or square root of 7/3. What problem does this have? What problem do we all have? No, this one violates rule number 3. There should not be any fractions and any radicals. This was an attempt to hide a fraction inside a radical, and everyone can see it there. So the first thing we're going to do is we're going to split it up. And then we're going to say, oh, okay, I've got a square root in the denominator, but I can fix that square root by multiplying by the square root of 3. Now, why does that fix it? Well, because the square root of 3 times the square root of 3 is the square root of 3 times 3. Now, up top, we've got 7 times 3. That's not going to be as helpful. But again, this is not about making everyone look nice. It's only about the denominator. Really, we have a favorite child. The favorite child is the denominator. The numerator, we don't care what happens to the numerator. It's going to be a mess. And it's okay. The numerator is used to this. They're cool. They are also a superhero because they can handle this. Up top, I've got 21 inside a radical. Down on the bottom, I've got 9. Now, 3 times 3 gives me 9. What's the square root of 9? You got it. So what have I done? Well, yet again, I took a square root in the denominator and I basically shoved it up top. Now, the other problem we have is this 21 and this 3 are winking at each other because I really want to reduce this and make it 7 because that would be lovely. But this is a 3 outside a radical and this is a 21 inside a radical, and they do not talk. So this is it. We cannot reduce this. Be strong. Do not be tempted to reduce those. Leave it as is. Okay, you ready? Let's do it. I wish I could sing music, but I can't because YouTube thinks I'm swearing at you, and I don't want YouTube to think I'm swearing at you. I'm not swearing at you. I worked really hard not to swear at you. There's a whole class of that in the imaginary teacher school that nobody goes to. Fun fact, college professors are not required to take any teaching classes at all. Fun fact. Okay, cube root. Oh, man. First thing, split up the cube root of the numerator to the cube root of the denominator. Now, here's where I'm going to teach you something that's going to start off looking a lot harder than what other people are going to teach you. But in the long run, it will be quicker, smarter, and better. Now, normally I would just teach you the plain version and be like, just whatever, everyone learns this, that's fine. But it really, since I was a student, the regular way that we're supposed to teach it just really upset me. And again, I can't swear, so I can't use the real words, but imagine colorful language. So here's the thing. If I just multiply by the denominator, like we did before, is that going to help? And the answer is no, because this is a cube root. 16 times 16 won't necessarily give me a perfect cube, and b times b will be b squared, not b cubed. So this is not going to work. Okay? So what we want to do, let me give myself lots of room. Is just like before with bare math. I want to look at who's in here. And I see that 16 is 4 times 4. Now I'm choosing just to use 4s, but you could also go to 2s. This would also work with 2s, so it depends. I see that 16 is 4 times 4, and I'm going to keep it simple by doing that. And I know I'm going to multiply by someone. So I'm going to give myself space. And then I'm going to come over here. Move myself over. I'm going to come over here, and this is going to be, and this is the thing about math. The great thing about math is it's, let's be honest, totally invented by humans. Now, the patterns are not invented, but the way we describe them, the way we write it down, the notation, all of these, the way we organize our thoughts, this is all invented by humans. So there's a lot of wish fulfillment that can happen in mathematics that can't happen in biology. You can't just be like, I would love a narwhal with wings, which would be cool. It'd be kind of like a unicorn Pegasus whale. But you can't do that in biology. You can do that in English, but not in biology. But in math, I could say, and I know you guys are going to be like, wait, this is nowhere near as cool as a narwhal with wings. And I'm going to agree. Yes, that would be, that is actually, I believe, mathematically speaking, a narwhal with wings is probably the coolest thing ever. And we could actually prove that, but that would be another lecture. So I've got a 3 bear, right? I've got 2 4s. It would be really great if I had 3 4s. I'm looking for groups of 3. So I look here, I've got 2. I need 3. I'm going to stick another one in. I'm also going to stick one up top to keep things balanced. Fractions have to be balanced. You have to do the same thing on top as on the bottom, and then you keep the fraction value the same. Now, I've got 1 b here. What I'd really like is 3 b's. So in order to do that, I've got 1, I need 2 more. And again, I will do that up top as well. So there are 3 over here. So let's see, up top, I'm just getting a mess. 5 times 4 times b times b. Okay, so let's regroup and look at what we have. Up top, it looks like I've got 20b squared. Down in the denominator, I've got 3 4s inside a cube root, so that comes out to a single 4, and 3 b's inside a cube root multiplied together, so that gives me a b. I look inside here, I say, okay, is there anything that's a cube or that has, are there any collections of 3 friends that can go running? Nope. This is our answer. Okay. This method is nothing anyone's going to teach you. Most of the time, they'll tell you to do something that is just, I find, personally offensive. Basically, they're going to teach you that the only way to wash a window is to knock down the house and build a new house with a new window, which is really just offensively wrong. It would work. Go ahead and learn it. You can learn it, but give this a chance. I know it's weird at first, but give it a chance. Hopefully, at least some of you will think, oh, okay, I understand what you're doing. And then the rest of you are like, you know what? I bet I wouldn't have to know this and still be able to get 90%. And the answer is, yeah, that's a big part of math too, is sometimes you work on the averages. Okay, I've got another cube bear. So let's see, I've got the cube root of a on top and the cube root of 25bc squared. So again, just like with bear math, I got 5 times b times c times c. And now I'm going to start putting together my wish list. This would be a lot easier if in the denominator, instead of 2 5s, if I had 3 5s, right? Because this is a 3 bear that we're looking at. So I only have 2, so I'm going to put it in a single one. Okay, got to put that top and bottom. Okay, b's. I've got 1 b. I need 3 b's. So I'm going to have to put in 2 more b's. 2 b's are not 2 b. I'm sorry, I can't help. I do that every single time. And then I already have 2 c's. I need a single c, and that will give me the 3 c's that I need. So I'll put a single c in up there. Up top, I end up with, let's see, a times 5 bbc, 3 5s, 3 b's, and 3 c's. So up top, I've got the cube root of 5a b squared c. Down in the denominator, I've got the cube root of 5 cubed, b cubed, c cubed. The 5 makes it out, the B makes it out, the C makes it out, and we are done. Bam. And now, because we're at 15 minutes, I want to give you, because it dawned on me, there's one problem I did not explain. And so I want to do one more problem. This will be number 4. This is bonus free extra learning just for you. And this bonus free extra learning is, what if I have, very simply, 1 over, let's do the 5th root of b to the 7th. Okay. So that is the number 5. Sorry, it's hard to see. 1 over, let me write it again so it's more obvious, b to the 7th. Okay, so 1 over 5th root b, 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 b. Right, I got 7, 1, 2, 3, 4, 5, 6, 7. Yes. Okay, I'm in 5th root, so I've got a 5 bear. So if I have a 5 bear, I'm looking for groups of 5. And I'm going to look and see, wait, these 5 Bs already have it together. They're ready to run. It's these 2 Bs that I have to worry about. So what am I going to have to stick in the denominator to compensate for these 2 Bs? Because I've got a 5 bear. This is a 5 bear. I want to multiply by 3 more Bs. Does that make sense? Because then I will have these 5, which are ready to go. These 2 will be joined by 3 more. So basically, I'm bringing in a rescue squad. These 3 Bs are going to help these 2 Bs run. These are both 5th roots, and as long as I multiply on top too, I'm golden. So let's look. Once I multiply, yes, I've made a mess up top. That's going to always happen. You're always going to make a mess on top. But down in the bottom, in the denominator, I've got, let's see if I've got enough room, B, 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 B. Got these 5, and I've got these 5. So I've got the 5th root of b cubed up top, and then I've got the 5th root of b to the 5th times b to the 5th, which is the 5th root of b cubed up top, and that's b times b, because each one of these make it out. So that's the 5th root of b cubed all over b squared. B squared or b square. Woohoo, math on. Next up, we will learn how to put these bad boys into equations. When you think this is fun, you're gonna love that. Actually, it's way better. But stick around, make it through the equation section, and then the very next one we're going to talk about is something called complex numbers. That is a trip. That is worth going on, I guess. Woohoo, math on. Did I make it?